All right, 26. So this one says, which of the following numbers is the slope of the line? And it gives it as 3x minus 2y plus 12 equals 0.
What was the question?
Which one's the slope?
Yeah, which this is kind of a dumb question because you can find the slope without calculus, but they want you to use calculus for it. So, anyways, negative 2y is equal to negative 3x minus 12, then divide by negative 2, so y is equal to 3 halves x plus 6. So I bet you can't guess what the slope is. So, we're going to take the derivative.
I just can't guess. Can't do it.
So the derivative is 3 over 2. So the slope is 3 over 2. Yay.
Wow.
Now this was a multiple choice question and the answer was I. So just in case you wanted to know.
The answer was I?
Like this was the option. This was like option 3.
Oh.
It was a multiple choice question.
I don't
So
think there's that one.
anyways.
That's just cruel. Like what?
Obviously, we didn't really need to do that, but that is how you would do it, using calculus. Okay.
It wasn't hard. I was like, really?
Just annoying.
Mm-hmm.
All right, find an equation for the line tangent to the curve at the given point. And so y equals x to the fourth plus 2 over x squared. X equals negative 1. So first of all, I know that I'm obviously going to ultimately need an xy point because I'm going to need point slope form to get the equation of my tangent line. So what is y in this situation if I plug in negative 1 for x? 3. So the point is going to be negative 1, 3 that I'll be using ultimately. So I like to just go ahead and get that out of the way because I don't have to worry about it later. So now we're going to take the derivative, and then we will get the slope that way and then find the equation of our line. So y prime is equal to, so quotient rule is, remember, derivative of the top times the bottom. So the derivative of the top is what?
4x cubed.
4x cubed times the bottom, which is x squared, minus the top, so x to the fourth plus 2, times the derivative of the bottom is 2x all over x squared squared, so x to the fourth. So now at this point, you can absolutely go ahead and multiply the x's through and stuff like that if you want. Or because what we need to do is we're doing it at that particular point, x equals negative 1, I can go ahead and replace x with negative 1.
Okay.
And do it that way. So I would probably just go ahead and replace it.
That seems smart.
So 4 times negative 1 is going to be negative 4. Times negative 1 squared is 1. So it's going to be negative 4 minus negative 1 to the fourth is 1 plus 2 is 3. So 3 times negative 2 is negative 6. So this is going to become plus 6 over the bottom to the fourth. So negative 1 to the fourth is just 1. So this becomes 2. Do we track what I did there? Okay. I'll just do this. Show that I'm plugging it in. So on and so forth. So this now is my slope. So I have a point and I have a slope. So I can use, so I can get y minus 3 is equal to 2 times x minus negative, so plus 1. You can leave it there if you want, or you can go ahead and multiply it through and stuff. So y equals 2x plus 2 plus 3. So y equals 2x plus 5. So either option here is fine with me. This is another one of those scenarios where in a multiple choice question on an exam, they might ask you for the point slope form. They might ask you for slope intercept form, or not necessarily ask you, but they may write it different ways. So just make sure, you're aware of that. All right, this next one's a little bit interesting, and you'll see why in just a second. So y is equal to x to the negative 4 over 4 minus x to the negative 3 over 3 plus x to the negative 2 over 2 minus x to the negative 1 plus 3. And we're taking the derivative of this still. It's the same instructions as the one we just did. So a lot of people get confused in this notation and tell me to take the derivative that we need to do a quotient rule. We do not. Okay? All this is saying is that this x to the negative 4 over 4 is 1/4 times x to the negative 4. Okay? So when you take the derivative, we follow the same thing we do when we have a positive exponent on there. We haven't really had many where we had negative exponents. So I still bring it the same way. So what does that give me for the derivative of this first piece? Yes. So we bring the negative 4 out front, and so the sign goes with it. So sometimes that also confuses people, but it's negative 4. So when we pull it out front, it's negative 4 times 1/4. 4's cancel, which gives it negative. And then, actually, though, this isn't right.
No, it's negative. Negative 5.
Negative 5, yep, because we subtract 1. So it's kind of weird because it's kind of like, well, it should be 3, but it's in the negative, so that's why. All right, and then this next piece, this negative x to the negative 3 over 3. Well, so I'm pulling a negative out front, so negative 3 out here.
Oh,
And it's negative, so this is actually going to
so
be
it's actually just X.
positive.
Okay, so it's
And then 3's cancel. So then I have x to the what? Yep. And then the next piece, x to the negative 2 over 2.
negative X to the negative 3.
Yep. And then the last, well, not the last piece, but, the last variable, I guess. Negative x to the negative 1.
Plus X to the negative 2.
Plus x to the negative 2. And the derivative of 3. 0, so I don't need to do anything with it. So this is, oh wait, this was slightly different instructions, sorry. It's like all runs together. You'll see why when you see the problems. We're not doing the tangent line. If we were, we would still just plug the number in and whatever, but that was specifically 2 problems that they were doing the tangent line for. All right, so are we okay with the negative exponents? It's, I mean, you see now how they work. It's opposite of, well, not opposite of what you would think, but probably opposite of what you would think.
Yeah, but we're gonna have to make a positive.
So, all right, one more that's just kind of weird because this isn't exactly something we've seen before. Y is equal to 2 square root of x minus 1 over the square root of x. So my guess is you probably don't know what the derivative of the square root of x is.
Your guess would be correct.
So I want to think about how else can I write a square root with something that I do know how to take the derivative of.
Oh, it's wait.
Ethan looked like he knew.
Yeah,
Mhm.
yeah.
Oh.
Yeah.
Can you just do like x to the 1/2?
Yeah.
Yep. So it's going to be 2x to the 1/2 minus, then this square root's on the bottom, so this is going to be x to the negative 1/2. And then now this makes it easier to take our derivative. You just need to remember when you're subtracting the 1 from your exponent, it is a fraction, so you need to do it as like 2 over 2, which is another way to write 1, just so you don't get confused. So the derivative of 2x to the 1/2 would be
Would be x to the negative half.
Yep, x to the negative half. So the 1/2 and the 2's cancel on it. So x and then subtract 2 over 2, so that'd be negative 1/2. And then what about the negative x to the negative 1/2?
One half.
X to the what?
Negative 3 over 2.
Yep, negative 3 over 2.
Okay.
And so, again, I don't care if you leave it this way. The book is going to do this, 1 over the square root of x plus 1 over 2 square root of x cubed is how I think they write it. Yeah. Oh, well, they actually do this. They actually do 2 and then x to the 3/2. What I just had would be fine, but that's how they write it. So again, more just a notation thing, but always good to be familiar with. Okay. All right, let's see what's next. Find the first 4 derivatives of the function. Okay. So this first one, gonna be kind of easy. Second one, might have to do a little bit of thinking. So 34, y is equal to x squared plus x plus 3. So the first derivative would be
2x plus 1.
okay. So then second derivative, so y double prime. So take the derivative of the derivative. It's 2. Third derivative, so y triple prime is 0. And then y to the, I say y to the 4th. Y, and then what we do is instead of writing 4 little tally marks or 4 little primes, we just write in parentheses a 4.
That's nice.
Just to show that it's, the 4th derivative. And the 4th derivative of 0 would be, the 4th derivative, so the derivative of 0 is 0. It's not meant to be a trick question.
Yeah, I was like.
Okay, 36. Y is equal to x plus 1 over x. So, I have here a quotient. So, just because of not getting confused, because when you start taking multiple derivatives, I know that my derivative is going to end up being a quotient every time, barring something canceling. So, I'm going to go ahead and just do this. U prime V minus UV prime over V squared, just so that I have that to look back to, because I'm taking 4 derivatives and it can get potentially a little dicey at times.
I don't like that.
All right, so the first derivative of the top,
Oh. 1.
1 times x minus, and I'm only, under ordinary circumstances, I would not write the 1, but I just want you to be able to look back and make sure you know what we did. Anyways,
Yeah.
minus the first one, so x plus 1, and the derivative of the bottom over the bottom squared, so that's x squared. So now this is x minus x, and then that's 1, so this is going to be 1 over, negative 1 over x squared. Okay, because the negative goes on the 1 over here as well. So basically, 1s are going away, and I'm just left with x minus x, and then minus 1. So now I'm taking the derivative of this negative 1 over x squared. Now, I'm going to pause really quick. A lot of people, rather than doing a quotient rule here, will rewrite this as negative x to the negative 2 and then just take that derivative, and that's fine. So you could do the quotient rule, or you could do it that way. Which way do you want to do it? It's going to give you the same answer either way.
To derivative. Not the quotient rule, the other one.
Okay, just take the derivative normally.
Yeah.
That's probably a good option, because the quotient rule takes a lot longer.
It does.
And your answer will be the same regardless. So, second derivative then would be what? So what's the derivative of negative x to the negative 2?
It would be QX the negative cube.
Yep. Now, the book may write it as 2 over x cubed. Either way, it's the same thing. If you did the quotient rule, it would show you 2 over x cubed, because something's going to end up canceling, which is why. If you had done the quotient rule from negative 1 over x squared. But it's easier to not do the quotient rule. But all right, so then the derivative of, again, I would use this one that's to the negative. So 2x to the negative 3.
Negative
Negative
6.
6 x to the negative 4.
Yep. And again, the book may write it as negative 6 over x to the 4th, so just be aware of that. And then the fourth derivative, so the derivative of negative 6x to the negative 4 would be
24x to the negative 5.
Yep. And again, they may write it as 24 over, whoa, that was a really weird 4. 24 x to the 5th, or 24 over x to the 5th, sorry. So that one was nice when it ended up working out that we didn't have to use the quotient rule over and over again. We could have, but some of the problems aren't so nice, and you have to use it over and over again, which just gets really time consuming. All right. Not much more, I promise. All right. Get ready for this problem. Find the tangent to the which of Agnesy y equals 8 over 4 plus x squared.
The what? The witch? That's too scary. I'm scared.
I guess it's because maybe it's like the Wicked Witch of the West from,
That's what I was thinking.
I don't know. This morning somebody told me that they like their neighbor or something has that in their yard. I was like, what?
What?
That's
Like
interesting.
the Wicked Witch of the West?
Yeah. They were like specifically that one.
Calendar. No, just they have the calendar. in
That's
there.
why
No,
I was asking.
I was like, Peyton, I thought you got what I said.
No, I got what you said.
All right. So y equals 8 over 4 plus x squared at the point 2, 1. I always think it's like when they make these word problems like so much more like in depth than they need to be. Like, why did we need to know that it was the witch of whatever?
Yeah, I do.
Like, not really relevant. So we're basically finding the tangent
Just to trick you.
at this point. So they already gave us the point, meaning what value am I plugging in for x when I need to find my slope? 2, yes. They just gave it to us a little differently this time. So the derivative of this is, so derivative of the top is 0. So then times the bottom, I don't even need to write that.
Oh wait, that's true.
0 times that is just 0. But if you don't write it, make sure you remember the minus sign. Okay, because it's that piece minus this other piece. So then the top, 8 times the derivative of the bottom. So it's the derivative of 4 plus x squared.
0 plus 2x.
2x over the bottom squared. So 4 plus x squared squared. And so again, at this point, I can just plug in 2. So that would give me, let's see, 4 times negative 8 would be negative 32 over 2 squared is 4 plus 4 is 8 squared is 64, which is negative 1/2. So this is my slope. And then the line would be y minus 1 is equal to negative 1/2 times x minus 2. So y equals negative 1/2 x plus 1 plus 1. So y equals negative 1/2 x plus 2. So the book is, I don't know what section it is that they go to point slope form, but at some point they do go to point slope form is how they primarily write their answers. Right now they're in slope intercept form. Couldn't tell you. All right, so now we're going to get into a couple of word problems because word problems are a favorite in the AP world. So, 2 of those, and then we'll be done. You might not say yay when you see how much homework you have, but I won't make it due tomorrow, though.
Get the A's back.
But I do think we're having a quiz on Thursday, so, you know. All right, so this says, all right, well, here, let me just give you the instructions to go with this section, and then I'll read the problem. When we work with functions of a single variable in mathematics, we often call the independent variable x and the dependent variable y. Applied fields use many different letters, however. Here are some examples. So the first one is cylinder pressure. So basically there's a picture of a cylinder, and they've got, like, a stopper that's pushing down on it. I'll show you really fast. Not that it's super relevant, but this is what we're talking about.
Yeah.
So, if gas in a cylinder is maintained at a constant temperature T, the pressure P is related to the volume V by a formula of the form, and so I'm going to go ahead and write this formula. P is equal to nRT, and it's a lowercase n and then a capital RT, over capital V minus lowercase n lowercase b minus a n squared, both lowercase, over capital V squared. In which, and I'm going to write this just so that it's relevant information, A, B, N, and R are constants. Okay, meaning they are what? No.
just not.
A constant is a what? Or what is a constant not?
Not 0.
Are you answering what a constant is or what it is not? I'm not saying you're right for either. I'm just asking which thing you're answering.
Constant is not 0.
Anybody else want to try?
Isn't a constant just a number?
Yes. Constant is a number. Like pi, like e, whatever. Okay? So that means that we also need to pop back and look at the problem, which said if gas in a cylinder is maintained at a constant temperature T, so constant temperature T means that what's also a constant?
T.
T. Then basically what's happening now is that we're going to be taking the derivative of this, okay? So basically it's with respect to volume, so it's going to be, I'm just going to write it as P prime, but if we wanted to specify specifically, we would say dP dV. So I'll do this just for reference for you if you go back, but P prime is what I would typically do. So basically, I've got two quotient rules going on here.
Yeah, sadly.
But what do I know about the top of my first one? So we're just going to ignore the second one for the moment. What do I know about the top of the first one? All those values are what?
Constant.
Constant. So the derivative of the top is
0.
0. So I don't even need to do the first piece.
Amazing.
But I do need to remember the minus sign. You're probably like, why is she emphasizing that so much? Because it's a mistake that I've seen before. People are like 0, so I can just keep moving. It's like, no, don't forget the minus sign. So now top, so nRT times the derivative of the bottom. So what's the derivative of the bottom with respect to V? So basically V is X.
V's X. Oh, okay. So 1.
1 because N and B are constants. So it's just 1. So I don't even really need to write it, but just more for reference.
Okay, so when something says like with respect to, that means that's the X. It's like,
Yeah.
okay.
So take the derivative of P with respect to V,
I don't know why. I thought they were going to give us actual numbers.
which is why I wrote it this way. Because
Oh,
this
I
is
see.
saying take the derivative of the function P with
D over
respect
D
to
of
V.
X.
And normally we have
Yeah.
dy dx,
Yeah.
which is the derivative of y with respect to x.
Mm-hmm.
So then over the bottom squared, so this is going to be V minus NB squared. Plus, oh wait. I lied. Hold on. We don't know that sign yet. Well, we might, but anyways, just, I'm going to do this. I'm going to leave a placeholder here for a sign because I don't yet know what it is. Because currently it's minus, but it could end up being plus depending on how this plays out. So, derivative of the top is
0.
times the bottom, so we can just get rid of that. So, minus, and then top, so an squared times the derivative of the bottom.
Which is
So, what's the derivative of v squared?
2v.
2v all over v to the fourth. That's v squared squared. So now, this was a minus sign here, so this is what I'm going to do. This was a minus sign. There's a minus here now, so when I rewrite this, it's going to become plus between.
Okay.
Okay? So, to rewrite this, to make it look a little prettier, negative nRT over v minus nb squared plus, and now I'm just going to write this as 2a n squared v because, you know, not OCD, but I like my letters in the right order. Over v to the fourth. Now, what else can I do? Or is there anything else I could do? Because I always want things as simple as possible.
Can you like cancel out these on the one side?
Yep. So finally, this is going to be negative nRT over v minus nb squared plus 2an squared over v cubed. And you could have done that in this step up here, and that would have been fine. That's really what I should have done, but I didn't register that I was doing that until I rewrote it in that order. Something about the order it was on top threw me off. I don't know why, but anyways. All right. What is 52? Oh, 52 is similar to this problem that we did yesterday. This one, 24. But it's a word problem now. So let's walk through this. This is the last one. We're done. Okay. So this one is picnic pavilion rental. The members of the Blue Boar Society always divide the pavilion rental fee for their picnics equally among the members. Currently, there are 65 members and the pavilion rents for $250. Okay. The pavilion cost is increasing at a rate of $10 per year, while the Blue Boar membership is increasing at a rate of 6 members per year. What is the current instantaneous rate of change in each member's share of the pavilion rental fee? So basically, we're going to set this up and take a derivative, essentially. So m of x is going to be the members x years from now. Because we know how many there are initially, but every year that number is changing. Then we're going to have p of x, which is going to be the pavilion cost x years from now. So the cost, which ends up being basically per member, is c of x is equal to the cost of the pavilion, so p of x, divided by m of x, which is the number of members. Okay? So now, we're considering this to be year 0. Okay, it's the initial year, so we're considering that 0. So now is where I'm going to set it up like we did in 24, okay, where the stuff was given to us. So I'm going to have m of 0, I'm going to have m prime of 0, I'm going to have p of 0, and p prime of 0. And so the prime values are what the increases per year. Okay? So the initial number of members, it said, was 65 members. The initial cost is $250. Then the increase is $10 a year for the pavilion. So P prime of 0 is 10. And the number of members increased per year is 6 per year. So M prime of 0 is 6. So I am now trying to find the derivative of P over M. Okay. Which is going to give me the instantaneous rate of change, aka slope. Okay. So the derivative of this would be derivative of the top, so P prime times M minus P times M prime over M squared. And so then this is where it's back to 24. We just plug the numbers in. P prime is 10 times M is 65 minus P is 250. M prime is 6 over M squared is 65 squared. And just to save you from getting your calculator out, this is going to be negative 0.20, which means, what is the current instantaneous rate of change in each member's share of the pavilion rental fee? That means, because it's negative, that it is going down by about 20 cents per year. Per member, basically. So, I know that's a lot, and you might not have gotten there on your own. At least initially. Okay? But it's more like I just wanted you to see it, and it'll help you. I am going to give you one that's similar to it to try on your own. But it's not one that I would, like, stress a whole lot over. Okay. Now back through here to find what all the problems are. Because have I given you any problems yet?
You've given us up to 23.
Okay. Okay, up to 23. So, adding on. I know this is going to seem like a lot. 25, 27, 29, 31. And you're probably like, why is she giving us so many back to back? Those are actually all different types of problems. Minus 29 and 31 are the same time.
The lights kind of flickered.
Y'all saw that too, right?
Yes. That was not what you doing. My number is like 8% smaller.
Okay, 33. Which is also a different kind of problem. 41. 47. And 51. And 51 is going to be very similar to 52. It's orchard farming, so it's